You want to give yourself a chance. All right, so we're going to talk about, first of all, factors. I'm going to ask you a question like, what are factors of 6? Do you guys know what factors are? Right?
They taught us in high school, but I forgot the...
All right, I'll remind you guys about factors. Factors are the numbers that divide 6 without a remainder, meaning the remainder is 0. Okay? And they're actually positive numbers, okay? So when they ask you, what are the factors, they're asking you what are what? All of the factors, not just some. So we have to list them all. So I want to remind you, or I want to say this to you. The best thing to do is to start to do this systematically, meaning start with the smallest number and go all the way up to the number itself. You're going to see what I'm talking about. So when I want to check, or I want to list all the factors of 6, if you guys recall, what you're going to do, you'll try 1 goes into 6 how many times? 1 goes into 6 how many times? 6. What's 6 times 1? 6. Subtract and you have a what? There's a 0 remainder. So if your remainder is 0, that means 1 is a what? Factor of 6. Let's check. Is 2 a factor of 6? 2 goes into 6 how many times? 3. What's 3 times 2? 6. What happens when you subtract 6? You get 0. What do you guys notice? Is 2 a factor of 6? Sure is, because it has a 0 remainder. Now what's the next larger number after 2? 3. So you say, okay, let's check if 3 is a factor of 6. 3 goes into 6 how many times? Twice, and 2 times 3 is what? 6. What's 6 minus 6? 0. So 3 is a what? Factor of 6. It's pretty nice. This is what we mean by factors. So far we got 1, 2, 3. What number comes next? 4. 4 goes into 6 how many times? Once. 1 times 4 is 4. Subtract. What's 6 minus 4? That's 2. Do you guys know that's a remainder of what? 2. What does that mean about the number 4? It's not a factor. In order to be a factor, it has to divide the number with a 0 remainder.
I remember this in high school.
Yep. What about 5? Is 5 a factor?
No.
It's not. How do you guys know? 5 goes into 6 what? Once. 1 times 5 is 5. Subtract. You got a 1. 5 doesn't work. What about 6? 6 goes into 6 how many times? Once. And 1 times 6 is 6. Look at that. You got a 0 remainder. So what I'm saying to you is that if we had to list factors of 6, what are they? 1, 2, 3, and what? 6. 4 and 5 are not factors. So you might want to write them down. So write them down as your list. Okay, I'll put them right here. 1, 2, 3, and what? 6. Okay, what I went through in detail is the process you go through when you want to find factors of a number. Okay, and believe it or not, it's an important first step, because when you first learn this factoring technique, the world of factoring, and factoring is going to be here for a long time. You're going to do factoring a lot. So that's why I'm saying what I'm saying and going through it. You want to start with start with 1 and end with the number. And then you can list all the factors of 6, because we're going to talk about not just factors, but the greatest common factor. Okay, you guys okay with that?
Yeah.
Let's give you another example. What are factors of? I'll give you an example. We're listing factors now. List factors of 4. What are the factors of 4?
4 and 2.
Well, how do you want to start?
Oh, 1 divided by 4.
You want to start with you want to go systematically, because if you did any, meeny, miny, mo, what's going to happen? What do I mean by that? If you didn't start with the number 1 and you just took an arbitrary number and checked, that's not a good approach. You know why? Because you have to list what? All of them. And if you do it arbitrarily, you're only going to list a best sum. Okay, so I'm going to start with 1. Is 1 a factor?
Yeah.
What about 2? Does 2 go into 4?
Yeah.
How many times?
2.
What's the remainder? Okay, good. Is 3 a factor? Because 3 goes into 4 once, but the remainder is 1. And is 4 a factor? Okay, good. You guys okay with this? All right, let's try another one. We're going to list factors here. List the factors of 8. What are factors of 8?
1 divided by 8.
You're going to start good. You start with 1. 1, what else? 2, 4, okay. Nate, can I give you guys a secret or a trick?
Yes.
Once you get halfway, like what's half of 8? 4. Once you get to that halfway mark, there's not going to be any other factors other than the number itself. Isn't that a nice trick? You guys know what I just said? Let's take a look. What's half of 6? 3. Once you got to the 3, the only other factor is going to be the number itself. So you really only have to go halfway. Once we got to the 4, the number itself. Huh? Let's try this out. How about the number what? 24. We'll go through it. How do you guys want to do this again? Systematically. Start with the number. What number do you want to start with?
1.
1. Okay. Is 1 a factor of 24?
Yeah.
What else?
2.
2. Good. And then? 3. Okay. Is 4 a factor? 4 goes into 24 6 times. What about 5? No. 6. Good. 6 goes into 24 4 times with the 0 remainder. How about 7? No. 8? Yep. 8 goes into 24 3 times. What about 9? No. 10? 11? How about 12? 12 goes into 24 how many times? 2. And you get a 0 remainder. What do you think? What's half of 24? 12. You want to know what you could now say? Don't check any of the others. 24, the number itself will be a factor. Okay? So I just want to say to you, once you get to the halfway mark, in some ways you're done. The last remaining factor will be the number itself. Do you guys know why? Because every number has 1 and itself, 1 and 4, 1 and 8, 1 and 24, 1 and 6. Every number has 1 and itself as factors. Okay? How about this? Let's do another one. What are the factors of 7? 1 and what? You guys okay with that? 1 and 7? Are there any other numbers? 2? No. 3? 4? Are we halfway? If we check 4, what's half of 7? 3.5? So just put the number itself. 7's a factor of 7. 7 goes into 7 once with the 0 remainder. Do you guys notice anything special about 7 versus the other numbers? Yeah, this is actually, if you guys recall, this is the definition of a prime number. It's a number that has only 1 in itself as its divisors. Prime. Okay, you guys okay with this?
Yeah, my memory's coming back from this.
Exactly. We want to be able to list these what? List all these factors. So I'm going to ask you guys, try 15. I'm going to have you guys do some more. On your own, we'll go over it. 28. 25. 36. 12. 9. 27. Didn't we smell anything here? Is it just me? Huh? I don't know. Somebody smells like flowers or something. It has some perfume or something. Who smells so good here? Is that you? What is it? What's it called? Juicy? Who sells it? Oh, really? I'm like, man. I'm like, is that me? That smells so good today. I don't smell one. That must be me. No, it's not me. Man, that smells so good. Okay, what are the factors of 15?
1.
1, what else?
5.
3, good at what else?
5.
And 15. Is 7 a factor?
No.
No. How about 10? No. How come 10? Well, it goes into 15 once, but the remainder is what? 5. Okay, good. What about 28?
1, 2, 4.
1, 2. What about 3?
No.
No, 3 doesn't go into 28, does it?
No.
4?
1.
Oh, 6. Does 6 go into 28? No. 7. 8. 9. 10. 11.
14.
The next one I think is what? 14. And are you halfway? Then what's the last one? 28. Look at that. All right, you guys okay with this? Like I said, you want to work on finding that greatest common factor. That's the foundation here. What about 25? What's the greatest common factor?
1.
1, what else?
5.
5 and 25. What about 36? 1, what else? 2, 3, 4, 5, no, 6, 9, what comes after 9? 12, there's 13? I think it's 18 is the next one, and notice they're not halfway? 36. Those are all my factors. Factors of 12. 1, what else? 2, 3, 4, 6, and 12. I'm halfway, aren't I? What about 9? 1. How about 2? 3, 4, 5. Aren't I halfway? Then what's the last one? 9. Good. 27. 1, 3, 9, and 27. Good. Now let's see if you're really awake. We're listing factors of numbers. But what I'm going to ask you guys now is, what are the factors of the variable x? How do you factor x? What do you guys think? Huh? You guys want to do it systematically. What do you start with again? 1. Does 1 go into x? What do you guys think? Does the number 1 go into x? Do you guys remember that procedure we worked on called dividing polynomials? How did we do that? Do you guys remember? I'm trying to see if 1 goes into x. Does it? Well, how many times? What was that first step? It said x divided by 1 is what? What is anything divided by 1? Itself, good, x. So this is x. What's x times 1? X. What happens now, okay, I just want to point out, You did this before. X over 1 is x. This was my quotient. I put my quotient up here. Step 2, multiply. X times 1 is x. That's step 2. X times 1 is x. And then what's step 3? You subtract. Is that true? What's my remainder? You know what this means? 1 is a factor of what? Of x. Okay, you guys with me on this? 1's a factor of x. What else should we try?
Y.
Y? Nah. Y won't go into x because we don't know the value of y, do we? So what else do you think we should try symbolically? 2? Well, we don't know the value of x. Try x. Good. So x, does x go into x? How many times? What's 1 times x? Subtract, what do you get? 0 remainder. Is that true? What does that mean about the letter x? It'd say what? It's a factor. So if I had to list the factors, what are they? 1 and what? X. These are my factors. Okay? And in some ways, doesn't this feel like it's prime? You say, what are you talking about? Yeah, any number and itself as the only divisors is prime. So in a sense, this is also prime. Just in a sense. Now, you can't tell me, okay, try this 3 divide x. Well, we don't know the value of x, so we don't know. Does 4 divide x? We don't know. But I know x divides x, and I know 1 divides x. Without a remainder, those are my factors. Okay, so you can't really, we got to keep it simple here. You can't say, how about try z? The z, we don't know the value of x or z. So x has 1 and x as its factors. Let's see if you're really awake. What about x squared? What do you think the factors of x squared would be? Well, what do we know again? What always works? 1. What else? And itself, x squared. Is that right? Or is there anything else that might be a factor, you think? 2. Well, I mean, again, you get what? Here's the x squared. You're going to check 2. Let me go through step 1. What's x squared divided by 2? You don't know. Why don't you know? You don't know the value of x. We can't say 2. We can't say 3. You don't know the value here of x still. So what do you think we should try? Good. X. You say, well, how come we could try that x? Because I know x squared divided by x, we have a property. What was that? Isn't that just x again? Isn't that x to the, okay, 2 minus 1 is what? X to the first power, which is just what? X. So I know x goes into x squared how many times? X. Isn't that the division you guys worked on in that sheet? So step 2, remember that process was x times x, which is x squared. You're going to subtract. You get a what? 0 remainder. So what do we just discover? That x is a factor of what? X squared. You guys okay with this? Do we have to check 1 and x squared? Or are you guys okay with that? Well, the answer for the factors are 1, x, and what? X squared. Okay? Those are my factors. That's what you guys are learning new today. So in some ways, like you said, okay, I did this in high school. Good. Good. What you guys have new today is what? This version. All right. Can I erase this here? You guys have this? You okay? Okay, here we go. What are the factors of x to the third power? What do you think they might be? 1, what else? X, okay, good. What else? X squared and? Good. Interesting. You okay with that one? How about if I change the letter? Or do you guys like the letter x? let's do y to the 4th power.
Same thing as x.
Okay, what do you mean?
Like 1.
Good.
Y squared.
Well, don't forget y.
Y.
And then what?
Y squared.
Y squared and then?
Y is it
Okay, after that?
y 4.
There you go. Anybody notice a pattern here?
Yes.
What's the pattern?
The power.
Start with 1 and raise your powers to the term itself. Okay, you guys okay with this? Of course, we're almost there. All right, anybody have any questions on the variables? We're finding factors of these variables.
No.
Any questions on that part? Should I check? Let's see. Let's give you guys a quick test for a couple of them. How about if I gave you x to the 12th power? How about if I gave you y to the, 35th power? What are the factors?
1.
Just look at this. What are you going to start with?
1.
1 and then x and then x squared and then, you know what we're going to do? Let's put 3 dots and then put an x to the 12th. You okay with that? Meaning that pattern continues. You say, what's the pattern? The powers are increasing by 1. This is called ascending order, not descending. What about the y? Should we use that trick for the y?
Yep.
Start with what again? 1 and then y squared, y cubed, and have that go on forever to y to the what? 35th power. Those are your factors. Okay, you okay with this? Whew. You guys okay with that stuff? Well, you're going to have to go through the definition. In other words, you say, what do you mean? Well, let's try this one. What you're going to need to do now is this. One goes into what? X cubed. What else? X goes into what? X cubed. What else? X squared goes into what? X cubed. And then x cubed goes into what? X cubed. So 1 goes into x cubed. You're going to do that division. You're going to do all these division problems. How many times does x go into x cubed? X to the 2nd power. What's the next step again? X squared times x is x what? Cube. Subtract. What do you get? 0 remainder. If you get a 0 remainder, that means this is a factor. It's on the list. So what I'm saying to you is, guess what you're going to have to do then? Go through your division and verify for yourself until you become a believer that you're going to get what? 0 every single what? Time. Now, some people need to be convinced. Some people are already convinced. Okay? Some of you guys already know. Yeah, I can see 1x squared to work. Oh, yeah, I know. 1y squared, y cubed, y to the 4th. Okay. Y to the 35th. Do I want to do this problem all day long? No, you might have to rely on your what? Faith. And you go, I believe you. Because I could change that power if you say, I still don't believe you. Okay, you don't believe me? All right. Let's change this power to what? Y to the 435th. You'll be a believer like what? Like that. What's going to happen with every one of these remainders? You get 0 remainder. That means it's a what? It's a factor. Okay, can I erase this here? Because what I'm going to give you now, the title of this worksheet is really called Factoring by First the Greatest Common Factor. So in order to look at the greatest common factor, okay, let's talk about what the greatest common factor would be. Well, first of all, it has to be a what? Has to be a factor, is that right? Has to be a factor. And then it has to be what? common. So we got to talk about what that means. We abbreviate this simply as GC, what? F, greatest common factor.
Well, isn't that when you get the big number and then you go to a smaller number?
Well, let's see what it is. Let's look at the greatest common factor of 4 and 8. So if they say to us, what is the greatest common factor, or what is the, well, it's not LCM. It's in a sense, it's kind of like a distant cousin. It's kind of related. It is related, LCM and GCF, but don't think of LCM. Okay? Don't think of the least common multiple. No. We're thinking what? Greatest common factor. And you say, what do you mean? Well, what's the greatest common factor of 4 and 8? So let's talk about this. Or let's try 4 and 6. I think I erased it. We started with that one. Greatest common factor of 4 and 6. If you list factors of 4, and that's what you want to do, list factors of each number. So factors of 4 are, you already know, is 1, 2, and 4. Factors of 6 are 1, 2, 3, and 6. These are my factors of each number. Is that true? So we're looking at the factors of these two numbers. When you talk about greatest common factor, the context is looking and comparing factors of more than one number. Here it's 2. More than 1 means 2 or 3 or 4 or 5 or 10. So I'm comparing the factors. I have to locate the common factors. What do I mean by common? Yeah, is it common to have hair? What does that mean?
Everyone's born hairy.
Well, everybody has hair in their head, don't they? Wow. Wow. In this room. Is it common in this room to have hair? Is it common to have, everybody have a pair of eyes? Okay. Everybody have a mouth? Is it common to have a mouth? Is anybody here with their mouth is missing? No? Okay. So it means that it's pretty what? It's common. What we mean in math about common is that it's on both lists or every list. Isn't 1 common? Because it's on both lists. What about 2? It's on both lists. What about 4? Once you go through the items in a list, you're done. In other words, I'm not going to check to see if 3 is common or 6 is common. I already know 1 and 2 are the only common factors. So this is common what? Factors. We talked about both of these items. What do we need to know now? What does the greatest mean? The largest. Is that true? So of the common factors here that I circled, which is the largest?
6.
Well, is 6 common? No. What did I circle? The common factors. So what are you going to say? The greatest common factor is what? 2. Two is your greatest common factor. So you're looking for the largest common factor. Okay, you guys okay with that? This is the process you have to do in your head pretty what? Fast. Now you may say to me, but wait a minute, Mr. Judge, I mean, I can't do that. I can't get there yet. Oh, that's okay. That's why you're going to practice what? Every day. Does practice make perfect? Mm-hmm. So you go through these procedures I'm going through with you, and you start to get better and better and better, faster and faster, and then that's how you improve. What about the greatest common factor of, let's say, 15 and 25? Let's try this. Okay, factors of 15 are what? 1, 3, 5, 15. Factors of 25 are 1, 5, and what? 25. Which ones are common? 1. What about 3? What about 5? What about 15? Nope. What's the greatest common factor? Okay, you go, Kate. Can I erase this here? Okay, so we're looking for greatest common factors now. Is there any limit to the number? Do I have to only look at 2 numbers for the greatest common factor? I mean, how about if they gave you this? What if they gave you 8, 12, and 14? What's the greatest common factor of these 3 numbers? I don't know. Let's list the numbers. 1, 2, 4, 8. 1, 2, 3, 4, 6, 12. What about 14? 1, 2, 7, and what? And 14. Is that true? So you're going to circle the what? The common factors. Common, in this case, means that the number is on all 3 lists, every list. It has to be on every list to be common. 2 is on every list, isn't it? What about 4? It's on the first 2. Is it on the last list? No. What about 8? It's on the first list, right? So what's the greatest common factor? 2. Everybody okay with this? You guys okay with finding the greatest common factor? You sure? Let's give you some more examples. Three, 6, 18. It's the greatest common factor of 3, 6, and 18. Well, let's see. 1 and 3. 1, 2, 3, and 6. What about 8? 1, 2, what? 3, 6, 9, 18. Are there any others? Did we miss any? Okay, let's see. What are the common factors again? 1, 3. It's on every list. Anything else common? So my greatest common factor is going to be 3. Greatest common factor of 12 and 7. Well, let's see. Let's go through it. 1, 2, 3, 4, 6, and 12. And then 1 and 7. Is that true? So which is common? 1. Which one's the largest? Is it 1? So the greatest common factor is the value 1. You guys okay with that one? Anybody have any questions so far in these?
No, I remember these from now on.
But it's a process, is that true?
Yes.
And it's important because, like I said, what I notice when people really get this process wrong, where you may say, where do they make their mistakes? Well, a couple things. It's going to be arithmetic, maybe. But it's also the systematic issue. In other words, people may not list their factors what? From small to large. They do it eeny, meeny, miny, mo. That's not the best way to do it. That's not the best way to find it. You got to do it systematically sometimes. Okay, how about this example? How about if they say, what's the greatest common factor of x and x squared? Let's go through the process. What's the greatest common factor of x? 1 and x. Isn't that in your notes? What about x squared? 1, x, and what? X squared. Circle the what? The common factors. What do you guys think? So the greatest common factor here is what? That's just what? X. Is that easy, or is that, in some ways, this is the new part. Greatest common factor of the variables. X squared, x to the 4th. Greatest common factor. Let's see. What are factors of x squared? 1. What else? X, and then x squared. What about x to the 4th? 1. What else? X squared. Are you believers yet? What comes next then? X to the 3rd, and then? Anybody notice something interesting? 1. What else? X. What else? X squared. Are there any others? So what's your greatest common factor going to be? Let's see if you're awake. 1 and x cubed. What's the greatest common factor?
1.
How do you guys know? Well, for the 1, isn't it just 1? Okay, what about x cubed? 1x, x squared, x cubed. Okay, what's common again? 1. What's the largest? Well, that's what it is. Okay, good. Greatest common factor is going to be what? 1. Nice. Let me try something out here with you. What about x to the 2nd power, x to the 3rd power, and x to the 5th power? What's the greatest does anybody notice a pattern even with the greatest common factor for your variables? What's the pattern? It's x to the what? It's x to the smallest what? Power. What is x to the smallest power in this case? Anybody want to tell me? Good. Is that a nice little trick or tattoo to get? You guys see what I'm saying? Wasn't it x to, what's smallest power? 2 or 4 here? 2. What's smaller? 1 or 2? 1. 2, 3, 5. 2. And then, are you ready for this? Greatest common factor. Here's another example. 4x squared and 6 what? X. How am I going to find the greatest common factor of these terms? In other words, what do you guys notice? You got numbers and letters. So how do you deduce the answer when you have numbers and letters? What do you guys think? Just checking if it was on. Yeah, you want to do them separately. Do the numbers first and then do the what? Letters. So what's the greatest common factor of 4 and 6? You guys already told me. It's going to be 2. What about x squared and x? Greatest common factor is 2x. You guys with me on this? So what do you do? How do you do this? You do them what? Separately. 4 and 6, you already told me it was 2. X and x squared, you already told me it's what? X. So if you do them separately, the answer is what? 2x. 15x to the 4th, 25x what? Squared. You have to find the greatest common factor of the numbers and the what? Letters. How do you do them again? Separately. What's the greatest common factor of 15 and 25? How do you know it's 5? Is it here? You guys notice why I leave it up? Sometimes people forget. They already did this. They found the greatest common factor of 15 and 25, and they forget. They already got it. What about x squared and x to the fourth?
X squared.
Which is smaller?
X squared.
There you go. Because that's again what people what? Noticed. So you may say to me, how do I convince myself again? How do you convince yourself? Is there any magic words? Does Mr. Judge have magic? I'm not Harry Potter. I can't wave a wand. So how do you convince yourself? Let me go back here. I'm going to erase this. First of all, does everybody notice x squared and x to the fourth? We already deduced it was x squared. You want to know? Go through this what? Procedure. You say, how many times do I have to do it? Enough. What's enough? Back again. Thank you. How many times is enough? For one person, what? 10 times. Another 20. Some of you guys, you're already there. You already believe that it'll be x to the what? Smallest power. You say, how do you know? Because you went through this process.
Aren't we looking for the greatest common factor?
Yes, we are.
First time that was in the smallest power.
Because that's what it is.
The smallest is the greatest.
No, don't oversimplify. You guys, remember I said to you, what's the biggest? Well, let me go back. Don't oversimplify. Don't pay attention to only half the story. In other words, don't say, hey, we're looking for the greatest, and then it's now smallest. Are we looking for the smallest? No. You're looking for the greatest common what? Factor. It just so happens with variables, when you follow your what? Process. When you go through the, what's the process? Finding factors. 1x, x squared. 1x, x squared, x third, x to the fourth. Which are what? Common. 1x, x squared. When looking for the greatest common factor, isn't that what it is by your process? The answer is yes. Okay. You found the greatest common factor. That's what we called it. And what did it turn out to be, though? It turned out to be x to the smallest power, even though you're looking for the greatest common factor. So in one way you could say to people, why is it? Because that's how that is. It follows by your definition. So just because you're finding the greatest common factor does not mean that this statement or observation that people made here is invalid. You see what I'm saying? The greatest common factor does involve language that involves the smallest. So here in this example, did we do the numbers separately? 15 and 25? It's 5. You got the number here? What about x squared and x to the fourth? X squared. If you don't want to get that tattoo, do you have to get it? No. Then what do? Go through your process. Don't even what? Say, you know what? I'm not ready for that tattoo. Here we go. We got some time. Here we go. 15, 25. Let's change this next one. What if they did this to you? Let's see if you're really awake. Eight x cubed, 12x squared, and 14x. What's the greatest common factor? How did you get that so fast? Because you already did what? 8, 12, and 14. You did the numbers and then the what? Letters. X to the third, x squared, and x. Do we have that anywhere? Do we have that in our notes anywhere?
No, but you could visualize.
Yes, you can. What do you say to somebody that has no vision? It could be a problem. Well, if you're blind, I guess there's a way to feel it. You guys know that? You use Braille. And now let's see. This is only for let's see if you're really awake. 3x to the 6th power. 6x to the 4th power. 18. What do you guys think? Well, you got numbers and letters. How do you do this again? Do the numbers separate from the letters. So what about the numbers? 3, 6, and 18. We already did it. It's what? 3. Now let's see if you're awake. Let's do the letters now. Let's see how you guys deduce this. X to the 6. X to the what? 4th. And then what? There's no X. Let's think about this. There's no X. This is called critical thinking. Do you guys know what I'm saying? So if there's no X, can X be common? Say no. It's not even what? Common. Therefore, what's the conclusion? You're done. 3 is the what? Greatest common. Did I say common? I said common factor. What does it mean to be common? It's in each term. So if X is not in that term, it can never be what? Common, if it's not in that last term. Does that make a little sense?
Yes.
Is that kind of wild? Well, that if that X is not there, it could never be common? No. Here we go. Now let's see if you're really awake. I ran out of numbers. How about this? 12xy squared. 8x squared y. And then 4xy. You mean they can give me what? Numbers and 2 variables, 2 letters, x and y? How do you handle this situation? One at a time. Do the numbers first. 12, 8, and 4. What's the greatest common factor? What is it? Is it 4? How do you know? What if you don't know? Did we do it 12, 8, and 4?
Yeah.
Did we? Are you sure? All right, let's see. What are factors of 12? 1, 2, 3, 4, 6, 12. What are factors of 8? 1, 2, 4, and 8. What are factors of 4? 1, 2, and what? 4. Is there any law that says you can't do that? If you're first learning this, what should you do? This? Or do you believe in Harry Potter? Is this my wand? You could do it now? Here we go. 1 is common. What else? 2 is common. What else? 4 is what? Common. So 4 is the greatest common factor of 12, 8, and 4. That is why. Now, let's compare. X squared, and what? X. What's the greatest common factor? Now let's do y. You do them one at a time. Let's try y. Y squared. Y to the first. Y to the first. Well, is there any difference between x and y? So what do you think? What's the greatest common factor of y squared and y? How do you know? You went through this what? Process. We got a few minutes. What time we get out of here? 12:10. See, everybody's so trying to rush out that door. Was it lunchtime or something?
Yep.
Is that what it is? You got a pizza waiting for you?
Yep.
You got some pizza? Oh, sushi's waiting? You guys have some sushi out there waiting for you?
Oh yeah.
Oh, man. Cheeseburger.
Ugh.
Pastrami.
Ugh.
Chili cheese fries.
Ugh.
You got that all waiting. You're ready to jump out the door. All right, ladies and gentlemen, this is your first step in factoring. I suggest you what? Yes, I suggest you guys do this night and day.
I remember this stuff in high school. They showed us.
Here we go. We're going to factor out the greatest common factor here. This procedure we work on, you're going to work on for the rest of your life. So you guys really want to follow up on what we're doing here. I'm going to give you a recipe. It's based on what we did yesterday. So for example, if you had something like x cubed plus x squared, and your instructions are to factor out the greatest common factor, well, guess what? Here's what you're going to do. You're going to follow this procedure, this recipe. Step number what? 1. You're gonna do this. You're going to determine the greatest common factor for the terms. And in this example, your terms are both what? X cubed and what? X squared. Okay, so you got two terms. What's the greatest common factor of x cubed and x squared? Good. It's x what? X squared. You okay with this? That's your first step. You're going to follow this procedure. Okay, so we went over this greatest common factor yesterday. That's the idea. Now, step number 2 is going to be the following. I'm going to call this step 2. I'm going to say to you to determine the what? Determine the quotient. You're going to determine the quotient. And you say, what do you mean the quotient? Well, go back to the original problem that you have to factor. What is it? It's what? It's x cubed plus what? X squared. You're going to have to divide by, what are you going to divide by? You're going to divide by the greatest common factor. You always divide by the what? Greatest common factor to get that quotient. In this case, it's x what? Squared. You with me on this? This gives you what we call the quotient, because when you divide and get an answer, it's called the quotient. So now you have what? X cubed plus what? X squared over x squared. And then you get this x cubed over x squared plus an x squared over x squared. We're finding the quotient. This is your original problem you had to factor, the greatest common factor. Don't remember that. Don't forget that, I mean. Now you have two division problems. Properties of exponents are at play. So what's x cubed over x squared? This is just x, right? Plus, what's x squared over x squared? You have found, what did you guys just find in this step? You have found the what? The quotient. Okay, you're going to follow this recipe, this procedure. When you woke up this morning, you may not have been familiar with this recipe. That's okay. So you're going to, step 1, find the greatest common factor for your terms. Step 2, determine the quotient. And then you guys know what you do in step number 3? Let me write it up here, step 3. Step 3 is you're going to write your answer in the following format, because you're really done. The answer is the greatest common factor times your what? Times your quotient. So in this problem, what was the greatest common factor? X squared. I'll put it here in black. What was the quotient that you just got? X plus 1. So ladies and gentlemen, you have factored out what we call the what? This is the greatest common factor. That's your procedure that you use for every one of these factoring problems that are factor greatest common factor. Okay, so what I'm going to tell you is that you're going to probably learn about 3 or 4 different factoring procedures, but they're all based on this. This is your foundation. This is where you start. Okay, so you want to take it serious because like I said yesterday, you're going to see factoring where? For a long time, for the rest of your life. And it's a pretty important tool and idea. But anyway, anybody have any questions on that procedure? Is it easy procedure?
X2, just write 3 plus X2, and then for the GCF, you write X2.
That's x squared, yeah.
X squared,
And then find your quotient. And once you already have the greatest common factor, you got your quotient, you're done. That's the procedure for factoring out the greatest common factor. So then, how many problems you guys do to make it stick? Enough. And how many might be enough? 100, 20, 30, 40. Everybody, it's different. Okay, so we're going to do some more. And notice that we're going to follow the procedure. Okay, and like I said, you guys want to do that because you're going to see factoring for a long time. And, we'll do some easy ones. You have to really work with factoring. What if you had 8x minus 24? And again, we have to factor out the greatest common factor. Right? So what's your first step going to be if you thought of step 1? Step 1 is what? Okay, what is the greatest common factor of 8x and what? And 24? The terms. Anybody know? 8. Good. That's your first step. Step 2 is to find your quotient. You say, what do you mean? Start with the original problem. 8x minus 24 divide by the greatest common factor of 8 you found in step 1. So remember, if you're going to divide 2 terms, divide them separate. So you get what? 8x over 8 minus 24 over what? 8. So when you do this division, you guys remember, what do you have now? Doesn't the 8's cancel? You have x minus, what's 24 divided by 8? 3? This is what we call the what? The quotient. So you found your 2 pieces of information. You're now ready to write your answer. So here's the answer. What's the greatest common factor again? 8. What's the quotient? X minus 3. So you can write your answer this way, that 8x minus 24 is equivalent to 8 times x minus 3. Okay, you could write it that way. Or you could just write it as 8 times x minus 3. Okay, but I want to point out another important thing to you. If you're at a cocktail party and the issue of factoring comes up, okay, and they ask you, hey, what is factoring anyway? Do you guys recognize anything here? What is it? Yes, it's the what? It's not the distributive property. It's the reverse of the distributive property. You mean I took this term and I wrote it as what? 8 times x minus 3. It's a special version of that distributive property in a way. Okay, so notice if you multiplied but don't multiply because they're asking you to what? Factor. This will be your answer is what I'm saying. So factoring for us right now is the reverse of the distributive property. Take a look. X squared times x is x cubed. X squared times 1 is x squared. So it is the reverse of that distributive property. So we're really working in reverse of this term. That's one way to look at factoring. Sometimes people say factoring is writing a sum or difference as a product. Okay? This is a difference. You wrote it as a what? Product. This is a sum. You wrote it as a what? Product. So you're at the sort of beginnings of your factoring career. And like I said, factoring is a very, very big thing. When I teach 125, I don't review really factoring. People have to go in there knowing how to factor. So in our remaining time, we're really gonna practice our factoring skills because it's important.
Are you going to teach 125 next semester?
Yes, I am. I'm going to be in 125 next semester. So let's see. Let's give you guys some more to do. A handout. This is called the factoring, greatest common factor and by grouping. So here's what I'm going to do. Let's try this. 3x to the fourth minus what? 12x squared. You're factoring out the greatest common factor. So step number one, what is that one? Huh? What's the greatest common factor of 3x to the fourth and 12x squared? Well, for 3 and 12, isn't that 3? X to the fourth, x squared, what is it? Is everybody okay with this? For step one? I'll write it out as GCF, sorry. 3x squared. Are you guys okay with that? Step number two, we have to find our quotient. So start with the original problem. Divide by the greatest common factor. Okay? So this is 3x to the fourth over 3x squared minus 12x squared over what? 3x squared. You got two division problems to do, right? What do you notice? Your 3's gone. What do you end up with? X squared minus, your x squareds are gone, right? What's 12 divided by 3? That's 4. Okay, what does step 3 say? Write your answer. How do you write the answer as? 3x squared times x squared minus 4. Final answer. Remember, it has to be in the form of a greatest common factor and a what? And your quotient. And again, that's times here. Okay? So you go through these 3 steps when you factor out the greatest common factor. All right, you guys okay with this?
Yeah, it makes it easy to understand.
You got to go through your recipe. And that's what you're going to do, show you how to factor by these techniques. You got to build people, build them up, I guess. Notice this. What did we do yesterday? Talk about that greatest common factor. That was a vital step. Here we go. Let's give you guys some more here. How about this? 6x squared minus 3x plus 15. You may say, wow, you can have 3 terms to do here? Yes. Okay, so step 1. What's the greatest common factor of 6x squared, 3x, and 15? Just 3. Why not an x? It's not even common. This term doesn't have an x. Okay. So the greatest common factor here is going to be just the number 3. All right, let's see step number 2. You have to find this quotient. So I take the original problem. 6x squared minus what? 3x plus 15 divided by 3. So you get what? 6x squared divided by 3 minus 3x divided by 3 plus 15 divided by 3. So what do you guys get for a quotient, right? 6 and 3 is what? Is that 2x squared? Okay, and then what do you got? 3 and 3, what is this? Minus x. plus, what's 15 divided by 3? 5. Here's your quotient. So we got our quotient, greatest common factor. Step 3 is the answer step. So you're going to say step 3. What do we put down? 3 times what? 2x squared minus x plus your 5. You're going to follow your procedure. Okay, you follow that recipe over and over again until you factor, like crazy. So let's give you guys some more. Anybody have any questions on this here? How about if they gave you 2x squared plus x?
Greatest common factor of the x. It's gonna be x. It's gonna be the GCF.
Well, what's your first step? What's the greatest common factor? Is it just x? Okay. What if you said, what number's in front of this x? It's a 1. Can you think of the 1 if you wanted? Sure. What's your greatest common factor 2 and 1? 1. So you say, is it really 1x? Well, yes. But we usually don't put the what? The 1. Okay, you okay with this? So here's your greatest common factor. You're halfway there. All right. Step 2. You have 2x squared plus x divided by your x. We're finding the quotient. 2x squared over x. X over x. So what do you get now? Is this what? 2x plus 1. Bless you. Here we go. We can write it here, step 3. X times what? 2x plus 1. We factored here. It's the reverse of your distributive property. Again, this is the first step of a bigger factoring strategy for you. This is just the first step. Okay? And it's doable, but you're going to have to keep up. Don't try to say, okay, I think I'll learn factor by grouping the night before a test. You don't want to do that. Okay? You don't want to put yourself in that position. So, anyway, here we go. Okay, here we go. Let's try to look at some of these. How about this? 24 x to the 8th power, y to the 7th power. Let's change this. 24, say x squared y minus 16 xy squared plus 8 xy. So now you have what? Not just the greatest common factor going to consist of a number, but also the letter x and the letter y, or the variables x and y. Okay? So factor out the greatest common factor. So what do you get for step 1? What's the greatest common factor? Well, for 24, 16, and 8, what is it? 8. Is it 8? All right, what about for the x squared, x, and x? Y squared, and y. Is everybody okay with that greatest common factor being 8xy? Okay, remember, wasn't this what we worked on yesterday? It's a big piece. Now, step 2 is something we didn't work on yesterday. We worked on that in the past. Okay, this is just a division problem now that we worked on in the past. So you're now going to divide 3 terms by your 8xy. So you end up getting 24x squared y over 8xy minus 16xy squared over what? 8xy plus 8xy over, bless you, 8xy. What do you guys end up getting when you divide, right? What's 24 divided by 8? Everybody know? What is that? So what's 24 divided? Is that 3? 3x, okay. Minus, what's 16 divided by 8? 2, and this is y squared and y. Is that 2y? Plus, what's this? 1. Here is your what? Quotient. So you got your quotient as well. Okay, your final answer is going to be in step number 3. (8xy) times your 3x minus what? 2y plus 1. Okay, you guys okay with that? And you're what? And you're done. So let's go through one more. Let's see if you guys are really awake. How about this? I'm gonna put a star here for a very good reason. So you have 2x, x minus 3, plus 5, x minus 3. This is a little different. Bless you. This one's a little different. What do you do here? Huh? Nah. I'm going to say here, think of it this way. I'm going to give you kind of this instructions. Your instructions here are going to be, think of it this way. Here's a hint. You're going to factor out, it's really the greatest common factor, believe it or not. Well, let me just say, I'll use the phrase common factor. But it's really the greatest common factor. So I want you to take a look at this and tell me what you might describe as being common. Good. Does everybody agree that maybe this is common, x minus 3? Because what did common feel like for us yesterday? It was in both what? Both terms? Okay, good. So we're going to note that x minus 3 is common. So in the last step, we would probably say, okay, this is the common term, x minus 3 in the last step. We need to multiply by some what? By some quotient. Is that true? So what I'm going to say to you is, what could our quotient be in this problem? Well, let's try to figure this out. What do I mean by, what's that quotient going to be? Well, let's look at step 2. If I took what I have here, right, it's 2x, x minus 3 plus 5, x minus 3. And I divide my terms by the common what? Factor of x minus 3. What did that mean again? Didn't it, yeah, aren't we dividing both terms? Meaning I got 2x, x minus 3 over x minus 3 plus 5 times the x minus 3 over my what? X minus 3. Because x minus 3 is dividing both terms. Do you guys see anything here? In other words, go back and think of your cancellation property. Don't I have a triangle and a what? Triangle. Don't I have the same term, top and bottom? Aren't I multiplying here? So what am I free to do? Cancel the x minus 3. Do I have an x minus 3 here and an x minus 3? Aren't I multiplying here? So what am I free to do? Cancel the x minus 3. What's left? 2x and a what? And 5. What do you think that's called? That's your quotient. That's right, it's your quotient. So the quotient is going to be here 2x plus 5. So I kind of lied to you in a sense. I said to you that factoring was the reverse of the distributive property. Well, it's not really a lie, it's a half-truth, because it is. But it's also the reverse of what? What would you use to multiply here? What's it called? It's not the distributive property. If you had to multiply this, you guys had that, I think you had it on your test even. If you had to multiply here, what's the process known as? FOIL, good. It's the reverse of FOIL. Factoring is the reverse of FOIL, ladies and gentlemen, and the distributive property. Okay, you guys okay with this? Isn't that interesting?
That's my answer.
Yeah, you're done. That's your step 3. So I want to give you this very special version here. I got to give it to you for a good reason. But let's actually do some more here so you guys can do this in your what? Sleep. Okay? Let's try another one here. Do you have to write all the steps necessarily? Huh? Well, if you're first learning this for the first time and you're saying, wow, I got to write everything down, then go ahead and do that. But, until you get better and better about it. But let's look at this example. What if they gave you x squared, x plus 5 now, minus 3, x plus 5. And I have to factor out my common term, or my common factor. I'm taking out the common factor. What's common again? Good. X plus 5 is common. So you can do what? Write down that common term, x plus 5. Now let's see if you're awake. What is the quotient going to be since this is that common term? What is it? How did you figure that out so fast? Anybody know? How did you figure out that the quotient was x squared minus 3 so fast? Anybody know? Well, sometimes some people say, okay, if I factor the x plus 5 out, they do this kind of in their head visually, I guess. What they do is they look at this and say, okay, I got an x squared times x plus 5. I have minus 3 times a what? X plus 5. I'm going to divide my terms by the x plus 5. Well, that x plus 5 is dividing both terms. Your x plus 5's cancel, is that right? What are you left with? X squared and a 3, and don't forget to what? Subtract. That's your quotient. That's what's left. When you divide both by the common factor. So this is actually what's going on here, okay? And it's going on for a good reason. Should we do one more? Are you guys okay? You want to see one more? Okay, let's see one more. You're going to factor out that common term. Okay, you factor out this common term. Do you guys see anything here that's common? What's common? 2x plus 5 is common. It's in both. That's what makes it common. So we're going to have here this 2x plus 1. It's not 2x plus 5, sorry. Okay, everybody see that common term? What's the quotient going to be? What is it? Is everybody okay with this? Everybody okay with that? Do you want to see the division? No. Do you want to see me cancel things? No. How about this one? What's common here? 5x minus 3 is common. You okay with that? So what are you going to factor out? 5x minus 3. And then, what do you need to write down? Don't you have to write down your quotient? Anybody know what the quotient's going to be here? 2x minus 7. So I think you're ready. You say, what am I ready for? You're ready for the last procedure today. This is going to be called factor by what? Grouping. You're going to factor by grouping. Now, factor by grouping applies really when you have 4 terms. Okay, it's not going to be so bad. Let me write it down here for you. We got 8x squared minus 10x. So for example, plus 20x minus 25. So how many terms do you guys see here? Are there 4 terms? So remember, factor by grouping applies to when you have 4 terms. I got 1, 2, 3, what? 4. You okay with that? So if you have 3 terms, is it going to be factored by grouping? No. If you have 2 terms, is it going to be factored by grouping? No. If you have 4 terms, is it factored by grouping? Yes. Here's what I'm going to do now. Let's give you the algorithm. Give you the procedure. Right? Step 1 is, well, this is where they get the phrase grouping. You're going to group the first 2 terms together. And the last 2 terms together. And you say to me, what does that look like to group the first 2 and the last 2? Well, you got 8x squared minus 10x plus 20x minus 25. What I do really is, well, I really don't even do this, but okay. Put a line under the first 2 terms. You just group those 2 in a sense. Put a line under the last 2 terms. What did you just do with the last 2? Group them. Okay, so you're going to group the first 2 terms and you're going to group the what? Last 2 terms. That's step number what? 1. Okay, you okay with that? All right, let me erase this. Anybody have any questions on the first step? No, what did you just do?
Factor out the greatest common factor.
Oh, well, that's not step 1. That's step 1 is just group the first 2. But guess what? You're pretty close. What do you think step 2 is going to be? I'll put step 2 right here. Here's your step 2. Factor each group, or I can say factor out the greatest common factor for each what? Group. Good. In other words, here, you got to write this one as a what? Greatest common factor times a quotient. You write this one as a greatest common factor times a what? Quotient. Okay, so that's step number 2. So step 2 is actually where we started today. Factor out your greatest common factor. Okay, you guys with me on this? So factor by grouping is 2 factor out greatest common factor problems. So, okay, let's write this down up here. So you say, okay, I have an 8x squared minus a 10x that's grouped together. Plus I have a 20x minus 25, bless you, that's grouped together. What's the greatest common factor of 8x squared and 10x? Is it 2x? You okay with that? Is that true? What's the greatest common factor of 20x and 25? 5. Aren't you adding these? This is addition. Make sure you pay attention to this sign. We'll talk a lot more about that sign. But what I'm saying to you is, this is your greatest common factor for the first two. 5 is the greatest common factor for your next two. What do you guys have next?
Quotient.
Find the what? The quotient for each. So I'm going to take this 8x squared minus 10x. I'm going to divide by what? 2x. Is that true? I'm going to take the 20x minus 25. I'm going to divide by 5. What quotient do you guys get here? Is that 4x minus 5? Anybody second that? What quotient do you get here? Is that 4x minus 5? Do you guys second that? You okay with this? Anybody have any questions on these two? All right, what do you think step 3 is going to be? Here we go. Step 3. Factor out the what? The common factor. In other words, what we just got through doing, you're going to do. What's common here again? 4x minus 5. Is that right? So I'm going to write down my 4x minus 5 here. And what's the quotient now? 2x what? Plus 5. Ladies and gentlemen, this is factor by what? By grouping. Here's your procedure. You're going to follow that procedure for every what? Factor by grouping problem. So write that down in your notes. Make sure you get that down in your notes. Because what you guys are going to have to be able to do is factor this what? Go through that procedure pretty fast. And when you first see it, you might be slow, and that's okay. But when you do it over and over again, you'll get faster, you'll get better. Did I put down your homework over there? What do you guys see? 5.1, what does it say? 15 is 62 what? All. Why would I give you all of them? Because you're going to get practice, and you're going to get that practice in, so you're doing faster and faster. And again, this is going to be for you for the rest of your life, factoring. So you'll be able to go through and say, yeah, I can factor. Yes.
Does it matter the order that you put it on?
Doesn't matter. Do you guys know what she's saying? She's saying, can I have written it down as 2x plus 5 times 4x minus 5? Can I write it this way? The answer is yes. Do you know why? Because the order in which you multiply, multiplication here, doesn't what? Matter. Factor by grouping here. Let's give you guys some more to do. Here we go. We get 8x cubed minus 2x squared. It's what? It just died? It's dying? Okay, when it dies, let me know. Plus 12x minus 3. Yeah, try this one. Okay, here we go. How do we factor by grouping? I'm going to change your format a little bit. I'm going to be a little more efficient. Group the first two and the what? The last two. What does step 2 say? Factor out the greatest common factor for each group. So what comes out here? What's the greatest common factor of 8x cubed and 2x squared? 2x squared, is that right? I need to multiply by some quotient. I don't know what it is. 12x and 3. Greatest common factor? 3. I got to multiply 3 with some quotient. Don't forget, what's the sign here? Plus. So now you guys have to tell me the quotients. Do your division. Right, you guys know you get what? 8x cubed minus 2x squared over that what? 2x squared. This one, what do? You get 12x minus 3 divided by 3. Get your quotients. 2x squared times what? What is it? Is that 4x minus 1? Is this 4x minus 1? Ladies and gentlemen, here's what I want to say to you. If you do this process correctly, what should you see here at the very end? This is going to be, yes, you should see this as the same thing. To let you guys know. And you say to me, why are you going to see the same thing? Does anybody know why you're supposed to see the same term here? 4x minus 1 and 4x minus 1. So that you can finish the what? So you can finish the problem. In other words, these problems are so very specially chosen that you can what? Do them. Meaning, you're not going to see something else here you really shouldn't see. If you do, either you did something wrong or the author was trying to check to see whether you knew what was going on. See what I mean? All right. So what is the last step? Factor out the common term. You told me 4x minus 1 is common, so what do you write down? 4x minus 1 times what? 2x squared plus 3. What's this called again? Factor by grouping. When do you guys want to go home and try your factoring problems? Today, as soon as you can.
The thing is, like, when I do it for myself, I feel like I'm not doing the right thing, even though I follow the same procedure. So I feel like it's not there yet.
Do you ever get any tutoring sometimes?
Yeah.
You do? Does that help, you think? Here we go. All right, here we go. Let's do some more. Factor by grouping. Should we do some easy ones or some hard ones? You want to do a hard one?
Yeah.
Okay, here we go. How about, that one looks really hard. How about 2x cubed plus 12x squared? Minus 5x minus 30. Here we go. Here's a really hard one.
Same procedure.
It's a procedure. That's right. Okay, group the first two. Group the what? Last two. Did you guys notice there's 4 terms? So no wonder it's under what? Factor by grouping. 4 terms. Okay, you okay with that? What do you do now? Step 2. Factor out the what? The greatest common factor for each term. Is that right? Okay, so I want you guys to try that out. Factor out the greatest common factor for each term. What do you think? 2x cubed, 12x squared. What's the greatest common factor? 2x what? Squared. Good. Don't forget, it's times a quotient. Now be careful here. What's the greatest common factor of 5x and 30? What is it? Focus on the terms. 5x and what? 30. Put your 5. You guys okay with this? Be careful. There's a reason I call this a difficult problem. There's a reason I'm going through it in this way. Okay, you okay with that so far? All right, let me say to you, how do we get our quotient now? Your quotient, you're going to do this. You take the 2x cubed plus the 12x squared, and you're going to divide by what? 2x squared. That's the greatest common factor. What do you get? Okay, you want to see every detail. Okay. That's x plus what? X plus 6. Is that true? Now let's try this. What are my terms here? 5x minus 30. I get 5x minus 30. I divide by 5. 5x divided by 5 minus 30 divided by 5. What's 5x divided by 5? Is that x minus, what's 30 divided by 5? 6. So if I go back and I say, okay, I found my quotients. Here's times an x plus 6. Here's times a what? X minus 6. And then you go, wait a minute. You just got through telling me 2 seconds ago that I'm supposed to get the same term here.
You will, because the negative in the middle.
Well, hold on. That's true. You're right. Did you guys hear what you said? Let's go back again. Aren't you supposed to get the same terms here and here? Are these the same? They're not. So that means we did something wrong. Is that right? I don't know. What was the issue again? What did you say?
You have to bring down the subtraction.
Yes. Here's what I'm going to say to you. See how this is minus? You see that's a subtraction sign we never really dealt with? Keep your minus sign here. You okay with that? Now, let's be careful here. This was plus. We just brought down addition. We brought down addition. This is minus. What's the difference? Well, didn't we say if we use the distributive property, let's double check. Isn't that negative 5 times x, which gives us negative 5x? Is this negative 5 times negative 6, which gives us positive 30? We don't have positive 30. We have what? Negative 30. Negative times a negative is positive. But that's negative. What do I have to do with this sign? Write it as plus. Now, is negative 5 times positive 6 negative 30? We're home free then. Notice, aren't they the same? Okay, so ladies and gentlemen, here we go. We're now ready to do our step 3. And our step 3 is to factor out the what? Common term. What's common is my x plus my 6. Now, what's my quotient? 2x squared minus what? 5. So, ladies and gentlemen, that's the move you make. If this is minus, put this minus and change that sign. And then you're home free. Okay, you guys wanted a hard one. Didn't you guys want a hard one? You didn't want a hard one? How many of these do you guys have to do again? Enough? How many is enough? Until what? Did the new Call of Duty come out yet?
Yep.
Oh, it did? When did it come out? Yesterday? Anybody an expert yet?
Tuesday.
It came out Tuesday? Anybody a general in Modern Warfare yet? Came out Tuesday. You guys are too slow. You are? Already, huh?
Yes. Modern Warfare 2.
Yeah, mine was there. And the other one.
I don't even buy the game. 'Cause if I buy the game-
If you don't buy the game, because if you buy the game, you're not going to factor.
Oh yeah, that's true.
And what's more important?
Factory.
Factoring's more important.
Factory.
We got some time. We're going to do some more. Let's go and play Modern Warfare or something. What if you introduce Does your fiance play Modern Warfare? No, he doesn't, does he? He doesn't play any of them?
Got the new Halo game.
You got the new Halo game too?
Yeah.
Did you imagine? You say, here's my fiance. Hello. You introduce him to your family. And what does he go do? He goes to your little brother's room and starts playing Modern Warfare? Is that terrible? But does it happen? It happens, doesn't it? I know it does. All right, here we go. Let's give you another hard one. This one's very hard. 7x cubed plus what? 5x squared minus 21x minus 15. You know what I had to go do? I had to go get like a 70-inch, what is that, HD screen? I had to. With Bose surround sound, just to play my Modern Warfare.
That's like $2,000 right there.
Could you imagine 70 inches of Modern Warfare?
Oh, I have a friend that has a TV.
Woo. Surround sound. I hear the bullet. I hear people sneaking up behind me. Nobody's behind me, but they're sneaking up.
You can see Dead Man's Hand much better.
Could you guys imagine?
No.
That's nice. No, you can get 90 now. You get 90.
They got those 4K TVs coming out.
Yeah. They don't make them big anymore.
My dad has a Mitsubishi big screen. It's a big one.
Does he really?
One of those big ones.
That's old school stuff. Yeah. You guys into what's better, factoring or playing Modern Warfare and surround sound and turn out the lights? And it's dark.
Oh, yeah.
You're a nerd.
I'm just joking. I don't do that stuff. You're just messing around. What are you guys? I'm just messing with you guys. You're like, wait a minute.
I basically go
I don't even know when that game came out. I'm going to race you guys home. I'm already a general. I've been playing since Tuesday. Why do you think I look so tired? No, I just think it's all funny all the time. You go, here's my boyfriend, and he's playing Modern Warfare. You're like, are you serious?
That's undateable, you know that?
Huh?
Talking about video games on a date, that's undateable.
I don't know. I have no idea. I don't know. 7, I know some of my students in a prior class, algebra class, that's where they're at right now. They're playing. They'd rather go play Modern Warfare than study algebra. Could you imagine? 7x cubed, 5x squared. What's your greatest common factor here? We got to group this. It's just an x squared. Good. We got x squared now. We need a quotient. What's the greatest common factor of 21 and 15? 3. You need a what? Quotient.
And it's going to be a subtraction. Not subtraction.
Now, how do you get the quotient again? Divide x squared into both these terms. What do you get? 7x plus 5. And then 3 goes into both. 3 goes into 21x. What's the quotient? 7x. 3 goes into 15. How many times? 5. What's supposed to happen? Aren't they supposed to be the what? The same? Aren't they supposed to be the same?
Yes.
What's that sign going to be?
Subtraction.
Step 3, factor out the common term. What's common? 7x plus 5. What's left? X squared minus what? 3. It's Modern Warfare time. We got to go home. I'll beat you guys home. I'm going to go play myself. All right, what's your homework again? We got that worksheet for you guys, and you have this bookwork. Make sure you spend this whole weekend factoring, because we'll do some more problems when we come back. Yeah, the worksheet's called Factoring, Greatest Common Factor, and by grouping.
Let's take Modern Warfare today.